Yeah.
Guys rolling?
Yep.
Alright. This is the C's of static. It's brought guide to the in-state of information, big data, and artificial intelligence, and the singularity, also known as right now. So, let's open this up with an analogy referred to earlier in the course. Earlier, Dr. Solas referred to the Tower of Babel as an infinite source of information. When one has all sources of information possible, it would be incomprehensible. We would never be able to find anything. But this came from a myth from the Bible that came 2,000 years ago when we didn't have today's technology. Does this analogy still hold up today? Are we doomed to drown in the sea of information that saturates the world around us? Is it possible to understand infinite or near infinite streams of data coming from every single faucet from the world around us? These are loaded questions, of course, otherwise I wouldn't be here. Data and you. Let's look at the definition of data. I think I knocked myself a bit silly. Data is the quantity, characters, or symbols on which operations are performed by a computer, being stored and transmitted in the form of electrical signals and recorded on magnetic, optical, mechanical, or, in this case, there are a few others, recording media. Now, let me open up with a question. How many of you have cell phones? One. You've got honest people. Good. These little things right here are some of the major contributors to the global datascape. Now, have any of you turned off the location services on your phone before? Good. By using your phone and many other devices, these things transmit your location, your browsing activity, in some cases your walking activity, your exercise rate, your heartbeat, in some cases, and plenty of other things you probably don't think of day to day. These are just one of the things that contribute endless amounts of data to the, well, global saturation of information. Typically, these are referred to as data footprints. These footprints here collaborate together to make the global datasphere, otherwise known as the collective quantity of data available. Now, as you can imagine, there is a lot of crap around. Now, just how much crap is there? In 2017, there was 2.5 quintillion bytes of data created every single day. In 2020, estimates show that each person will generate 1.7 megabytes every second, even people without technology. According to research performed by the IDC, predictions indicate that the global datasphere will grow from 33 zettabytes to 175 zettabytes by 2025. Of course, numbers are always meaningless if you don't know what they mean. So let's put some meaning to these big numbers. 1 zettabyte is 10 to the 21 bytes, which is 1 trillion gigabytes. Now, 1 exabyte is 36,000 years of HGTV, or the equivalent of streaming the entire Netflix catalog. 30,177 times. I hope none of you have watched Netflix that many times. In 2015, it will take 5 years to watch the amount of video that will cross global networks every second in 2015. Since then, global data traffic has been growing since, exponentially. Now there's 175 zettabytes to be floating around in 2025. That is a lot of information. Now, the solution, big data analytics, otherwise usually abbreviated as big data. The term big data is data whose scale, diversity, and complexity requires new architecture, techniques, algorithms, and analytics to manage and extract value and hidden patterns from it. It's the proper term for the algorithms, logistics, and management of such big data, but it's typically folded in big data for marketing and simplicity purposes, otherwise known as a buzzword. Now, of course, there wouldn't be much use for a giant pile of data and no way to analyze it, right? So let's take a look at some of these. proper processes to actually analyze all this stuff. First of all, let's talk about big data in itself. There are typically 3 V's, sometimes 4, of big data. Of course, you've already been bludgeoned to death with these terms, so let me just make this quick. There is volume, variety, velocity, and sometimes veracity. These are the important characteristics. Now, this is a little of a graphic making everything simple. Data volume, that refers to the amount of data you're dealing with. Typically, as you might imagine, big data does not involve scaling the entirety of everything ever at the same time. That would be just ludicrous. That variety refers to the variety that you're dealing with in data. Most of the web is unstructured. This would involve media formats like MP3s, videos, social media, anything you can think of. And finally, velocity. Velocity refers to the speed of the data that you're trying to process. Now, of course, the slowest that would just be a giant pile of data that's just sitting there in the middle of nowhere. Most places don't actually deal with simple batch data. Instead, they deal with a cutting-edge real-time or near real-time data streaming. Now, these slides will go into that a little bit more in depth. Again, volume refers to the quantity of generated data and stored data. The size of data usually determines the potential insight, whether it be big data or not. Big data volume is always increasing exponentially and shows absolutely no sign of stopping. If Moore's law comes to a stop, data growth certainly will not. Who knows how much data we'll have to process in the coming decades? 2035? How much will we have to deal with? 2045? Variety, of course, most of the data, or most of the web and data that we have to deal with is unstructured. It's not neat and sorted like SQL tables or, say, XML, column-separated diagrams, PowerPoints, words, all that. Velocity, speed, and finally, veracity. In the extended definition of big data, veracity plays a very important part. It is how accurate or truthful a data set might be, as the quality of the data captured can vary greatly. Big data is highly complex, and the result, the means for understanding and interpreting all of this is still being fully conceptualized. In short, big data is only actually useful if it's accurate, just as a full report on a subject with no validation, research, and accuracy is not applicable at all. For example, I could write a paper right now detailing about maybe 400 pages saying how great chairs are. That'll be useless to absolutely everybody except for like 2 chair enthusiasts. Now, a light overview of big data analytics. Typically, big data analytics are broken down into 3 important processes, the actual how-to of all this magical technique. First of all, there is storage, processing, and analytics. These are the 3 big things we have to deal with when dealing with big data. Storage is both an issue of recorded and live processing big data, and typically must be processed before advanced algorithms such as neural networks and whatnot can actually deal with this set. Of course, the depth and complexity of algorithms can vary all the way from normal statistical networks to neural networks, data mining, decision trees, classification, clustering, filtering, network browsing, and plenty more to boot. The full technical aspect of big data is a little bit deceptively complicated and not suitable for a presentation, but I will detail it anyways. So, first of all, let me step in front of this. For the storage of big data, or rather, extremely large sets, typically, this is usually stored in things called enterprise data warehouses, which, as you can probably imagine, is just a big stack of hard drives, SSDs, and other data storage sets. These are typically hard to actually process. They are very resistant to new analytical sets, and they are very hard to process with new algorithms that you may invent while storing all this stuff. Typically, storage methods that deal with exorbitantly large amounts of data need to be mad. Not just thinking, not that kind of mad. They need to be magnetic. They need to be agile. And finally, they need to be deep. When I say magnetic, I mean that storage, when dealing with big data, must be able to attract all sorts of different kinds of data. They must be able to deal with, say, MP3s and videos the same they attract, say, social media sentiment analysis or whatnot. When I say agile, they must be efficient when they're processing said data. If one were to, where did I put this? Let's take an example. Say you had to deal with 3 different types of data. We'll call them A, B, and C. If A took around 10 seconds, B around 3 seconds, and C around 5 seconds, we would want to minimize this data processing time. Now, of course, when dealing with a variety of assets, we want to try to process this variety of assets as quickly as possible. So, the example I listed would typically be normal for enterprise data warehouses. We just can't have that. And finally, they need to be deep, which just means that they need to actually store the full extent of the algorithms that we need to use to process all this stuff. Now, next there is, the processing of said big data. Typically, algorithms can't actually process, say, unfiltered, just random data you throw at it. You have to actually make something of it first. There are plenty of different types of processing methods, but typically it all boils down to one principle, the SVC principle. That stands for speed, consistency, and volume. Typically, when you're dealing with big data, volume cannot be something you skimp on. The basis of the SCV principle is that you cannot have all 3. You must give up either speed, consistency, or volume to deal with all this. So, you either a trade-off of SV, speed and volume, or CV, consistency and volume. Typically up to the implementer to see what they want. Now, there are plenty of different analytics, but I will give one very simple example of the Apache Hadoop system. The Apache Hadoop system is typically made of the, I think it was the HFSD file system and the MapReduce processing system. Now, let me explain MapReduce very simply. How many of you know what a sandwich is? Very good. All of you, very good. Now, let's take the example of a BLT. In a BLT, there is typically 5 ingredients. Bread, mayonnaise, lettuce, bacon, tomato. I'm not sure if mayonnaise is an actual thing. But say we had maybe 5 or 6 different BLTs together. The map part of this MapReduce would be taking our sandwiches and throwing them everywhere. By throwing them everywhere and decomposing them into their individual components, we can count what we have for each individual sandwich. The reduce part of our segment would be, as the weirdos we are from disassembling a bunch of sandwiches, we would take each and every single component of this, of the individual ingredients. You pile all the bread together, you pile the lettuce together, you pile the bacon together, the best pile by the way, tomatoes, and with that, you would be able to identify each and every single section of your data, where each characteristic comes from. Say you had a rotten piece of lettuce in your second BLT. With this approach, you would be able to see the percentage of lettuce rotten compared to your entire data set. And finally, if I was going to ramble on about analytics, we'd be here for a while, but there are plenty of different models that we can actually use to get information from this data set. One very interesting example is called sentiment analysis. This would be the method of taking a post from social media and whatnot and actually figuring out what people mean and their attitudes towards an object just by looking at their words. Of course, this would be extremely complicated. Typically, this usually works off Markov chains combined with maybe an ROC classification curve, but I won't go into that right now. There are several, ignoring all of what I just said, everything can be distilled down into 4 different properties. There are different analytical types, what you actually want from your data instead of just having information. First of all, there is prescriptive analysis, which is revealing what types of actions should be taken according to your data. There is predictive analysis, predicting what actions are going to happen. Diagnostic analysis, which is looking at why something happened. And descriptive analysis, which is what is happening right now. Finally, what's the point? With all the bells, whistles, and whimsicality of big data out of the way, why go to such lengths to datafy our world? What's good with making sense of this fabled Tower of Babel? What's the point? Anybody?
Get better.
Very correct. The answer is more information and data. Humans are rational creatures that make decisions from information and use tools, in theory. More information and more data can lead to better decisions and reveal new things about the world around us. Just like how a certain invention revealed the stars to humans, big data has the potential to reveal new things about the world around us. Of course, Galileo was a very influential man of his time. Just simply knowing more about the world around us can help us make more informed decisions. Say if we needed to know just how much pollution there was in the air, we'd be able to figure that out. Say how many people on the social media site like Facebook think about a single thing, we can figure that out. And one example, the human person. The human body typically contains around, it's arguable since we haven't done it in full yet, but the human body contains 10 terabytes to 100 terabytes of information. What if we could run analytics on that as a whole? These days, big data, machine learning, and artificial intelligence all appear to be converging on the same path. Why though? Memory? Faster algorithms? Better processors? Faster machines alone will not lead to progress. Artificial learning, machine learning, and big data change the nature of our problems. To put simply, machine learning and artificial intelligence require large data sets to figure out things around us. The problem has gone from, say, how to how can we learn about said issue. Typically, one thing most people tend to ignore is that machine learning and artificial intelligence require cleansed and sanctified, very clean training sets, which are very hard to gain. There was that one incident where, I believe, I forgot the exact details of the case, but when a certain hospital decided to have programmers come up with data sets, generate data sets, that led to very inaccurate results. So, how can we get these data sets? We can use big data analytics to get our data sets for our artificial intelligence. There are already many current applications for big data and companion technologies, from healthcare, manufacturing, media, to entertainment, government, and more. In education, there have already been several personalized and dynamic learning programs in place. There are several instances of course knowledge being reframed to a specific student's needs. Of course, there's also career prediction depending on how good a student does in their studies. And of course, acting upon this new information you've received, you can help guide that student to a brighter future. For healthcare, there's early disease detection reducing cost, efficiency. You can predict epidemics for the government. Messing that formatting up. There is welfare and fraud protection. Typically, big data is used very often to detect fraud in, say, tax forms, grant applications, and other forms. For entertainment, there's advertising, which was one of the first uses. You can personalize ads to people. You can get insights into people's shopping habits. Of course, personalized content. For weather, there's already IBM Deep Thunder, which is a service from IBM that can help to predict the weather up to about, I believe, 28 days in advance. Of course, transportation, route planning, traffic control, and congestion management. These are all different sorts of applications we have right now. And these are just scraping the surface of practical applications and simply just knowing more. Of course, there's even more that we're putting in place. Some more named applications would be the CDC. They're currently using big data analytics to predict epidemics, and big data combined with artificial intelligence to predict epidemics and analyze the spread of a disease. Google's already using big data in many of their projects, ranging from their search engines all the way to Google DeepMind. The Commonwealth Bank of Australia is also one of the people using fraud detection with big data in the world right now. Verizon is currently tracking people's or general consumer behavior to better tailor programs and data plans. Netflix is actually a very interesting thing with Netflix. Depending on the user's previous watches, people can actually get different thumbnails for certain things on Netflix. Say if you watched a bunch of romantic things on Netflix, you probably get a romantic thumbnail that would better draw you in. If you watch a lot of action, actiony thumbnail. Mint.com is a personalized, free, personal investment management site where you can actually see your own insights. If you input some of your financial data, you can see where your money is going, where you're spending it, the place you could optimize, and so on. Artificial intelligence and machine learning are technologies that thrive off data sets. I already mentioned this earlier, but some of the hardest challenges are for proper machine learning models. Right now, the data is becoming more meaningful, relevant, and breaks new ground for machine learning and artificial intelligence, even moves them from simple research lab projects to actual production, implementation in real life. Once the initial hurdle of lack of data is cleared, then artificial intelligence and machine learning can thrive. Right now, we have the tools to continue pushing progress faster than we have ever before. Researchers are finding constant new applications to both augment and uplift people's day-to-day lives. However, these are only practical applications of things happening right now. What if we were to work with machines as an improvement to our intelligence? Now, all of you have noticed that I may be using a lot of analogies right now. There's a reason for that. Analogies are powerful mental tools that are innately human. The ability to apply fine analogies from other domains has been fundamental to achievement across numerous domains, including architecture, design, technology, art, and mathematics. In 2013, a group of engineers partnered with a world-renowned origami expert helped to design a solar array that could be carried with the narrow rockets using analogy to origami folding techniques. There, as you can see there, they were able to fit the array into 1/10 of its deployed size. Salvador Luria advanced the theory of bacterial mutation by applying an analogy between bacteria and slot machines. And of course, the Wright brothers used an analogy to a bicycle to design a steerable aircraft. Very recently, I believe 2 months ago, there was a case study by PNS that was able to come up with brand new analogies for inventions and products in conjunction with human intelligence, or crowdfunding in this case. This is a simple first application, a test. There are plenty of other cases where we could, say, offload the creative burden to machines, let them do some of the thinking for us, and let us reap the rewards from it. Of course, the future ahead of us is very tenuous. As per the Singularity entails, we don't actually know what's past the threshold. But the application that we can potentially see in front of us are practically limitless, limited by our imagination. How do you think we have self-driving cars? Self-driving cars are built off data from all different sorts of vehicles in order to teach them how to drive properly. Stopping, driving, going, difficult speeds, best routes, all of that. There can be versatile new instantaneous healthcare framework. Imagine if we were able to predict almost everybody's diagnosis, maybe weeks, months, years in advance. We had everybody's information already identified. We have better voice recognition, search and information retrieval. If we were to train, say, a neural network or Markov chain off a large set of data, we could personalize search results to an even better extent we are right now. Finally, as I brought up earlier, there's understanding the human body. The human body contains about 10 to 100 terabytes of data. We have already been running several analytics on various segments. We've been able to run analytics on the cancerous cells in people's prostates, mammillary tissue, and I believe very recently we were able to accurately identify liver, cancer-causing liver cells. Again, this is just the start. With the projected Internet of Things, otherwise known as the Internet of Things, first of all, I forgot to explain this part, is in short a network of data coming from the world around us. From the advanced amount of sensors, cameras, and whatnot in the world, we're able to get more data than ever before. With all this in mind, big data has a bright future. Of course, all this does not come without its ethical concerns. When we're stepping towards the singularity, we should think about the logistics of some of this. One looming issue would be who actually owns all of this data? Do the corporations, do the people, do the governments? That is a very important ethical question to think about. Next, big data can compromise somebody's identity. If you were able to connect all the dots with a report you got, you could easily link a publicized report, say on something like perhaps criminal predictive analysis to somebody in real life. What if people decide to take vigilante action against that? Would it be right to publish this kind of data? We have to think about these things. We have to think about how to integrate big data and, in addition, artificial intelligence and machine learning into society. Most of the analytical examples I gave are still in the processes of design and testing. There's a major step between research and practical application. We have to think about how to integrate things with minimum conflict with our current ways of lives. Of course, there are plenty of other ethical issues that can be brought up about big data in and of itself. We have to be cautious before applying this technology to absolutely everything. As a singularity is in the distant or not so distant future, we can see that big data's contribution to science and society will be certainly a stepping stone. Now, a return to the Tower of Babel. In theory, infinite information is useless. However, have we finally conquered this hurdle? Have we conquered the Tower of Babel? Are we in the progress of it? This is going to be my opinion, but I'd say that we're currently making very good progress on it, and only time will tell if we truly have. References and more references. Any questions?
question. This is just your opinion. There's no right answer, but you were talking about ethical concerns, and something that I was thinking about is the ethical concerns of actual data collection. In that, like some previous presenters mentioned, like most of the time when we're asked if we're willing to share our data, we mostly just click through it because we just want to access what it is that we want to access, right? So even if legislature catches up to these kind of data collection and protection laws, it's going to be very different in like a liberal democracy like here versus other types of government systems where they can basically tell you like this is the data we're gonna collect from you and you have no choice. So although theoretically if we're using like these big data models to help people's lives, we want to be collecting as much data as possible to improve these machine learning algorithms. So should the people be given a decision on what to share, or should it just be something that you just share as a part of society?
I believe there's already some legislation in place to help people have a choice whether they want to actually contribute to, say, said big, or not big data, but a global data sphere of content. Personally, I think that people should be made aware of the value of their data. Data value is another big ethical issue because typically, people when they're clicking through all this, can we have all your stuff? Or not all your stuff, but all your information, they aren't actually aware of how much that is valuable to companies, governments, researchers, and other people working with these data sets. So if we could make some leaps in, say, social awareness to how much their data is worth. People could even sell their data for set amounts, and that would contribute to people actually wanting to give back their data a bit more. In fact, there was this one cafe, I believe I think it was SoCal, or was it Edmonton? Don't remember the exact details, but there is a cafe that is letting people sell their data for a free cup of coffee. Or that wouldn't really be free. Selling your information for, say, things like food, coffee. Would you take that deal?
Probably.
There you go. That's one way we can get more people to contribute to data if they don't want to.
You go first.
Just one thing I was kind of curious on that you mentioned early on in the presentation was that like everyone creates data, even people who don't have technology. So kind of how does that work, and like what kind of information can you collect if, say, someone doesn't have a phone attached to them, and like how does that play into the like macro picture? I guess what I'm asking.
Very good question. Say without our phone, just take this off for a sec. Without our phone, around us there are still sensors that can pick up on your information. Say if there is a sensor on, say, CCTV, there can still be a profile built up on you, even if you don't have something that contributes a massive amount of data to that sphere. In fact, even if you're... Okay, let's go with a rather extreme example. Say you are a Luddite. You have no phone, no computer, no nothing, don't even have a credit card. Paying with gold for... You're just paying with gold. Even then, depending on where you go, there's still sensors put into place that can still pick up on the data. It may not be data like your phone number, your shopping habits, your driving habits, even if you don't have a car either. But sensors in the Internet of Things around you can still pick up on data. So I am like actually, things like CCTV could still pick up on your location, your posture, your habits if you're ever caught. And other things like that could still pick up on you. It would be increasingly hard to not contribute data.
Thanks. Lots of interesting reflections on where we might be heading. But I took note when you said, we've got a nearly infinite amount of data. That it's just growing and growing, and can't believe how much there is. But I kept thinking that we only have data about the things that we can sense and measure. And when you really think about all of the possible data, we're probably only sensing and measuring a very small percentage of the things that we could be. So I'm not sure I agree that we have a problem of almost infinite data. I worry that we will exaggerate the relevance of the data that we do have and completely ignore everything that it never occurred to us to watch or to collect.
That's a very relevant topic, actually. There are plenty of different researchers currently working with the data sets that we have, that, so we can actually find more insights that we didn't know before about, say, the data we have. Like I mentioned earlier, sentiment analysis. That is a method to actually extract people's opinions from their words. Of course, before, maybe in like the old age of normal data mining, we wouldn't be able to find that. But I believe that as we are still developing different analytical methods, we'll be able to slowly pick up on more things around us as we develop better sensors, more sensors, place them everywhere. Eventually, we're going to reach that said infinite stream of data, but right now, as it currently is, we don't have an infinite source of data, just what we can detect, and we're working with that. Let me pull up one example from the information retrieval course I'm taking right now with Daniel Barbosa, Compute 397. That's a small plug right there. One of the concepts that we're working with is the idea that you can process data in live time, even if you don't have the whole image. By processing things one at a time and adding new information to your current data, you can still get insights, learn from the things around you, even if you don't have the whole picture. And when you do get the whole picture, maybe things will change. But that would also bring up the issue is, are we to trust these insights that we have from this partial data? Are they going to have some sort of bias that we don't know yet? That's still an issue that we're working on.
I just want to make a point of like how you said like our information matters, right? Like individually. I always think like when I'm like checking out these boxes, I'm like, oh, I'm just like one extra addition to the billions of people, right? So I guess my individual data doesn't matter, but as a whole it matters, right? So what do you? It's kind of like a paradox, I think, in that sense.
Yeah, you are right there. Each individual set, or rather, a singular entry in this whole sea won't really matter, but the entire thing does. Oof. Guess I didn't think about this one that much. But I suppose your information does matter because, bring up a statistical example, even one outlier can change your data set depending on what alpha values or fitting you're using. So it could matter. The probability of you being the person that matters a lot, probably not that high, but the idea of big data is when you have a picture of everything, you can figure out everything as well. If you don't have everything, then maybe you're missing something. Maybe the person who fits the trend of something you're trying to find out is currently missing because they didn't think the data mattered. Still,
Yeah, I mean, you can think about it that in a world where one person can make a big difference, then you need data on every person who could fit into that category, right? If we reach a point where one person can never make a difference, I would point out that's a sad world, and maybe then it wouldn't matter if we leave out a few people's data, you know, who the heck cares, right? So, but I think in the world of today, individuals can still make a tremendous difference. You reach a sort of threshold point where it could go either way, and one person's action shifts things, then becomes interesting. Well, how, why? So you need the data on that person. That's the world that we're living in today. And let's hope it stays that way so it's always possible. Yeah.
All right, any other questions?
So we're gonna go until 4:30, that's clear. You're not required to stay here, but we are gonna go to 4:30, so, and I can run camcorder. Many of you probably didn't know I had that skill, but it's possible, yeah, so. Okay, Caleb,
Alright.
you're on.